Hopefully from the previous video so far you are able to follow a simple application, and then a very simple smoke test suite with basic automation framework and all the different components which you have traditionally seen this, right? So far I hope you are able to follow. So now what next? Like in reality, in an enterprise world, okay, you will have lot more number of test cases, right? You may have some test data config files also that you may be feeding into your automation test suite, right? And also you may have some properties file or some configuration values, environment properties likewise, and there'll be little more complexity, but the fundamental building block is just similar to what we have seen here, and it is quite enough for us to kind of continue and see the scalable demo with this unit setup here. Okay, so when we have a lot number of test cases, like a test suite with hundreds of thousands of test cases, how do we scale the test run? So one of the way is like as supported by the TestNG framework, we run the tests in parallel, which we have done that configuration. Even here you can see that we're trying to run the tests in parallel, right? So that's one part of it. Second is, where do you run the test? So when you have to run a lot of tests in parallel, you need that infrastructure to support your parallel test runs, right? So the very popular infrastructure that goes in place is Selenium Grid, right? So you will have a Selenium server, and then you will have Node and Chrome browsers nodes that will be registered to the Selenium hub, and you can you can use those containers to scale your test run by executing the test remotely on those nodes, right? So that is nothing new. That is out there for some time. So now what is new? So this is what usually, if I architecturally show my system, this is what it is. I have a Windows box where I have installed IntelliJ and Java, and then pulled all the dependencies from Maven like TestNG, Selenium, and then I have written code to build this test automation scripts, right? So now I will execute this in a remote Selenium infrastructure. So that is not new, but the way we are doing it here is a little different. So we are going to bring up the Selenium grid infrastructure using Docker containers. So that way it becomes really, thin and really lightweight and highly scalable and very fast. Like you can bring up the containers just like that and execute the test. And after the test, you are going to kill all the containers. So this brings that, this brings down the cost. At the same time, it brings, a highly scalable model into place. We will see this entire thing in action in just a moment. Okay, so for this exercise I would be using Linux instead of Windows. So now the reason I am choosing Linux here is that Linux is more stable. My goal here is to run hundreds or thousands of tests in scale. So if I have to do this, Linux platform is more stable. It is free. It is lightweight when compared to Windows or Mac, thick clients. And there are images of Linux like Alpine, which is just 5 MB. But what I'm using here is a CentOS one. But there are images which are very lightweight, and it is free, open source, stable. And the another reason why I am choosing this Linux is that initially when Docker container technology was brought up, it was only supporting Linux, so it's very compatible with Linux. And now Docker is also supporting Windows infrastructure. So it's not that you cannot do it on Windows. If you like, or if you have a business reason to do it on Windows, you can also do it and scale Windows containers. Okay, but for the purpose of demo, I would choose Linux. So hopefully things are clear until now. Okay, so the next thing is I am going to prepare a Docker Compose file. Okay, so what Docker Compose is basically bringing up the Docker services, bring up all these things as a service. Okay, so I would execute these three commands on my Linux host in order to pull the latest image of Selenium hub, node Chrome, and then Firefox node from this Docker hub. Okay, so when I execute these commands, I pull the latest images, and then I will spin up containers using this image. I will spin up Chrome, Firefox containers, and these containers will in turn register to the Selenium hub, and I will get a Selenium hub node. So in traditionally, how I would interact with the Selenium grid, right? So similarly I will be able to interact even though it is all containers. How? I am doing a port mapping of 4444 to this Docker container, and through this port mapping, it is the Selenium grid infrastructure of containers is exposed through this port 4444. So I will be able to see the instances are up and running, coming up, running the test. I can see whether even using VNC Weaver, I can remote into these nodes, and I can test. I can see the running tests as well. But in this demo I will at least get to see whether the nodes are up and running or nodes are down. So I'll be able to monitor through this browser. So we'll see it in action. Okay, so let me get to the yeah. So this is my Linux host. I have chosen, this is a Linux host that is on AWS instance, but need not be. Okay, I can take up any Linux host that is out there. But for my purpose of this demo, I have spent a Linux instance on the AWS instance in the cloud. And now I'm in this path, and let me quickly look at the Docker Compose YAML file that I have prepared here. So this is the structure of the Docker Compose YAML file, which has three services like Hub, Chrome, and Firefox. And then as you see here, say, I'm pulling the image of this Selenium Hub and then mapping the port 44. Then I pull the image of Chrome and I register, you see depends on. So this is very important. So, because Chrome and Firefox nodes containers have to be spinned up after the hub is up and running, because they need to register themselves to the hub. As once they come up, they try to register to the hub, and if hub is not available, this setup will fail. So that's the reason I have this depends on hub as added here in both the cases, and hub underscore host is equal to the environment variable. The entry point is set to hub. Okay, so this is the Docker Compose YAML file. So now I quickly go to this AWS instance, and okay, I have ported the same Docker Compose YAML file here. You can use something like WinSCP kind of thing to kind of move files from Windows to uh, Linux. As I said, this is using CentOS. So you see the file, same Docker Compose YAML file which we just saw before in VS Code, right? So this is the file. So now if I say Docker PS, let me say Docker PS. See, I don't have any running containers as of now. Okay, so what I would do now is basically bring up. You will see that I say Docker Compose up. So when I say this, basically the code that I have written in the Docker Compose file gets executed, and it brings up my hub, and it also brings the Chrome and the Firefox instances here. This happened just in I would say a couple of seconds, right? And then the node is registered to the hub and ready to use here. So this is how I can bring up this grid infrastructure just in moment, so that I can run the test. Okay, so we'll see how we can run the test. Yeah, even though I just brought up everything in the console, I would lose the terminal. So in reality, how you do this is that you will say Docker Compose up and -d. So why you do this -d is to run this stuff in background. Okay, so just for showing all the logs that happens, I had to do it in the front, but now I just bring up the same infrastructure in the background. Okay, so let me see if it is running, right? So let me say Docker PS -a. Yeah, I see this, my Selenium, Chrome, Firefox, and Hub. The three nodes are running. So how do we see it from the grid console? So just to get the, yeah, as we saw here. Okay, so this is how you will access the grid console. This is the URL from where you can get, right? So practically we'll see, we'll just refresh this. Yep. So this is the my Selenium grid infrastructure. See, I'm connecting to the same Linux host of AWS from here, and then I'm able to see this Chrome and Firefox instance that are, just we brought it up. Okay, so now if I say, for example, Docker Compose. So if suppose I don't want to use it, that I don't want to run it, right? So I can bring it up in seconds. Sorry, I can bring it down in seconds as well. So I said Docker Compose down, it's all killed. So now if I say Docker Compose, sorry, Docker PSA, I don't see those containers. And here, if I refresh, they're gone. Okay. So now I can again bring it up. So it's what I wanted to show here is that it's so simple to, or so quick to kind of, spin up these instances, these Docker containers, and use it for testing, and then dispose after the testing. So that's the reason I call the disposable automation Selenium grid on Docker containers, right? So let me bring it up. So this is the the typical Selenium grid infrastructure that you would have with all the port mapping and all that. Just you may have a little latest version, or version could be different, but the concept remains the same. Okay. um, so now suppose you want to access it through the IP. This is the IP of it. So how IP of my Linux instance 3 dot which we saw here, right? 3.138.244.105. And how do you find that is basically just ping this AWS instance, you will get the IP here. Okay, this is the public IP. There is a private IP which you see here, um, uh, and there is a public IP as well. Okay. Okay. So now I have brought up the Docker Compose. I have brought up this grid infrastructure. Now I have to run the test. Okay. So let me try to run the test using this Docker infrastructure. Okay. So same test which I ran before. Okay. I go to this base test class. So previously you might have seen that there was, I was running the test locally on Windows browser, on Windows, right? So that's when I was using this. So now I just comment out this code, or I don't use this code, and then instead I point my test to run on a remote host. So these are the boilerplate code that you use to configure the remote grid, which you might be familiar with. So earlier my test was running on Chrome because I had it was made to run only on Chrome browser. Now I am not pointing to the Chrome driver or anything, the local path. So instead I am reading the browser property, and if somebody runs this test from the command line and provides the browser property or parameter as Chrome, then it will pick up Chrome, or else by default it will pick up Chrome. That's what I have written here. If not, if somebody gives Firefox, then it will execute on Firefox. Okay. Similarly, the hub. So if somebody provides that points to certain hub, then if it is not null, then it will pick up that hub. If nothing is provided, then it will go to my host, and my host is this AWS instance which I have given here. Okay. Yeah, you can even see this public IP on on the AWS instance here. It's the same. Yeah, um, on the EC2 instance. And now, yeah, this is how I get to run on the remote Selenium grid. Okay, so let me run the test now. So I'll run the same two tests. Let me run one of them, maybe in the interest of time. Let me run search page. Okay, and then as the test is running, let me switch to the grid console here, and then let me refresh. Okay, I mean, I haven't set up VNC. Even you can set up VNC Weaver and all that, and you can uh, or Selenium framework to kind of get into these nodes and see the running tests and capture video and whatnot, right? But for the simplicity of purpose of this demo, I haven't gone there. But I just want to see whether test is running and is picking up. Yes, sorry, I was looking at the Firefox one. So if I see the Chrome, it has picked up the Chrome browser here, and this is my test is getting executed now. My Chrome browser is Chrome node is busy executing the test. Okay, so now the test is run and it is completed and it is back. So the test has failed. So probably my application is down. So let me take a look at that. Yep, looks like my application is down. Let me bring it up and then run the test. Okay, so my application, I had shut down the pods, so I just brought up my application again, so it's up and running. So now I will try to re-execute the test and it should pass. Okay, so let me execute the test on the remote grid. Okay, so quickly let me switch to the grid console, and then let me refresh. Yeah, I see that my Chrome is busy and it's already executing. I should see the session. Yeah, I see this grayed out, and now once execution is done, yeah, the test has passed. So once the execution is done, it will become normal. During the execution, when it is busy, you will see it blurred. The image is blurred, and then when you go here, you will see that the session ID of the running test. Okay, this is a normal thing. So if you want to access it through the IP also, it's the same thing. Just let me quickly show that. Okay, so that's how we saw that how you could actually run the test using the Selenium infrastructure. It's a grid infrastructure which was brought up on the Docker containers, right? So now I will show you one cool feature. So how do you scale this thing, right? So suppose you bring up, let me okay, so now I killed all the instances. So if I say again docker ps, yeah, I don't have anything running. Okay, let me show it here as well. Yep, so it's down. So let me bring it up again, and then so by default, if you have observed, when you bring up this docker infrastructure, right? So I bring up one instance of Chrome, one instance of Firefox, and then the hub, right? So that's how my infrastructure setup is. But practically, as I told you before, right? So you have to run tests in scale. It's not sufficient one Chrome browser or one Firefox browser, right? You need a lot. So how do you scale? So that's quite simple and cool here. So instead of bringing up like this, so I'll just run this command. So like say docker compose up minus d, and then I say scale, and then Chrome equal to 4. Let us see what happens. See, if you closely observe this log, so it says, you are asking me to bring up this Docker infrastructure, which is already up. So I did not do anything. Okay, so the hub was already there starting. And then there was only one Chrome instance here. Previously it was running. So now I brought up 3 more Chrome instances for you. So that is what this command does that. So we can scale out and we can bring any number of Chrome or Firefox browsers and we can run tests at scale. And this also is happening at minutes. So this is how we see, right? So now I have one, two, three, four Chrome instances and one Firefox instance, as before. Suppose I want to scale Firefox as well, then I just do this. I say, I have for Chrome, so I need Firefox equal to, let me say, 2. Okay. Yep. So there was already one instance, and now there is one more instance that's brought up here. So if I say docker compose, docker ps e, so these are the images. So let me refresh here. It's still spinning, so it should get one more Firefox. That's what I'm expecting. Let me refresh here. It's one and the same. Yep. So I see that there are two Firefox instances here, and there are four Chrome instances as before, right? So this is how I can scale out any number of Chrome and Firefox browsers. And as I've shown you, I can run the tests in parallel, so using that way, so my tests can run on take advantage of this infrastructure, and it can run on multiple instances, and finish off very quickly. Okay. So even I can scale in. For example, right now we saw that how we could increase the nodes, right? So similarly, suppose I don't need so much, right? So then I can say docker compose up, and then I say scale Firefox back to 1, and then I can say scale my Chrome to back to 2 maybe. Okay, or maybe 1 as before. So what is happening now is it is bringing down the additional, you can see the logs here, right? So what is happening in the action, it's stopping and removing the additional instances. So now if I come back and I refresh here, okay, so this will be gone. Okay, so it will take some time to refresh, but you got the concept, right? So it will after 30 seconds the hub will keep checking for the nodes, and once it is not coming up, and it will bring it down. Okay, so this is how you can actually scale in and scale out any number of instances. You don't have to do any calculation here, you just need to say how much you need. Okay, so docker compose will actually do the backend calculation and spin up the delta instances for you, and either bring up or bring down. Okay, so this is how this is the second part of it, like how we saw that the how we could scale the test runs using docker containers, right? So eventually as we go ahead in this demo, we will see how we can containerize our automation scripts and framework setup, right? So how we can containerize that as well, and make it make a build of maven, and then deploy it as a java, like a java application, and then use this selenium grid infrastructure and the automation set of framework or scripts or application, I would say, like an automation deployed like an containerized application, right? So take all those three things together, and then fantastically orchestrate everything using Jenkins, and then execute the tests. So we'll see that whole thing building up, and these are all the building blocks into getting that. Okay, we'll see that in the demo. Thanks for watching and staying with me. Thank you.